all. So the today's topic that we are going to cover is about vCluster, also known as virtual cluster. So here we are going to talk about how vCluster, what is vCluster and how that helps in scaling your Kubernetes uh, um, as such, like whenever you are working with any Kubernetes cluster, how we scale it better, how we minimize the costing and other advantages of using the vCluster, right? So before we go to the next slide, let's see what is vCluster and the maybe a quick overview about it. Okay, so let's see. So the topic that we are covering, it's a vCluster deep dive, powering Kubernetes environment. That means when we work with the Kubernetes, there can be a set of requirement to be met before we can actually work with any clusters. Like we should have a certain permissions in place. We can only work with a few list of CRDs to install in a cluster. Okay, and when we are working with multi tenants, there can be a lot of concerns when we use the namespaces for just one tenant and the another namespace for another tenant. But the way they interact or the way we actually isolate them is much enhanced in case of vCluster. Okay, all right. So let's go to the next slide. Okay, so the very first question is why vCluster, or let's understand what is vCluster, right? So very recently, I came to know about this tool, this particular product. Okay, so the vCluster is basically nothing but a cluster inside the Kubernetes cluster, or you can say the physical Kubernetes cluster. Okay, that gives the tool Kubernetes a flexibility to scale the virtual form of those clusters and then create your own cluster where you will have the namespace with limited set of permissions. The size of the cluster is going to be very less. Okay, and as long as any developer has the right set of permissions, they can perform the task. Also, it helps in you can say a quick prototyping or maybe a quick sandbox that you want to give to any user for the testing purpose, right? Okay. Now, uh, if we understand what is vCluster, the the why is also very clear. So where you say it provides us the robust isolation. So when we talk about the vClusters, it offers a isolation based on the uh, the namespaces under which you work, right? So if we are aware of the Kubernetes concept, we know that any of the objects or the deployment that is done, they are actually separated based on the namespaces under which it is working. Now, in case of vCluster, we work with a single namespace under which the vCluster is installed or the virtual cluster is installed, which is present on top of the host cluster, right? The physical Kubernetes cluster, what we create or work with. So it is giving that opportunity to create your virtual cluster, work with it. If you are done with your requirements, then you have the separation of the cluster where you can actually get rid of it once the task is done. So it also gives in that sense very much a cost efficient approach, right? And obviously it provides a separation between the different Kubernetes cluster. Okay, we'll talk about the more of the use cases in later slides. So the two important pointers that we want showcase here is, first thing is robust isolation. That means you will have your own cluster. So suppose we are having multiple tenants or multiple clients, client deployments done in the Kubernetes and a single Kubernetes cluster. Now here you will be able to have a separate virtual cluster for individual clients. Okay, and then the workload will be handled separately for each of them. Okay, from the cost efficiency perspective, so it provides a secure multi-tenancy as I discussed so far. So it gives me a separate cluster for each of the tenant to work with, right? and that's how it is also able to reduce the operational cost, the amount of costing that it is going to take for managing multiple objects together for within just one physical cluster. Okay, all right. So let's go to the next slide and then see the differences or the advantage of vCluster here. Okay, so some of the key features as we see, first of all, it has its own API server. So like any Kubernetes cluster where we have the cross-plane and it has their own Kubernetes API server, virtual servers are also having a separate API server to interact with the external world. Okay, and then create another isolation and flexibility for handling those requests. Right. So now the physical Kubernetes API server will not be overloaded in that scenario. Okay. Another feature is lightweight and efficient. So the virtual servers, when we are talking about, it is actually installed on your Kubernetes physical cluster. So here in this scenario, it is going to be very light because it only has the limited set of objects or the uh, or any other components that we see in the full-fledged uh, Kubernetes. Okay. So, also by default, the virtual uh, cluster is actually using the K3s, the lighter version of Kubernetes, the K8s, right? So again, it is very much compliant with the Kubernetes requirement, but in a very limited set of objects, it is able to perform all those tasks, right? Okay, so on this table, if you see, we try to figure out what are the separation. I mean, what are the advantages of big cluster? So we have three columns here: separation based on the namespace, separation based on the clustering, and the weak cluster. Right. So if you see from the isolation perspective, when we have a separate namespaces, so in that case the isolation is weaker. But in case of virtual cluster, it is strong. Okay. If we have a separate cluster, that is very strong, but then again, there is going to be more costing involved there, right? Now, accessing the access for the tenants. So, in case of separate namespaces, because they are present in the same cluster, in same physical cluster, it is very restricted access for them. So they cannot have access to the obviously the control plane, but also they cannot have the certain other admin privileges that they may require for performing certain tasks, right? But in case of vCluster, we do have the vCluster admin permissions because individual clusters will have the access for the tenants. Okay. Similarly, for separate clusters, obviously the cluster admin privileges will be there with the each of the tenants, and there are advantages and disadvantages which we are able to see in uh, the other rows, right? So from the cost perspective, you see having a separate namespaces, it's very cheaper. In case of vCluster, it is going to be cheap, and then going forward, separate cluster obviously it will increase the costing because we are going to manage multiple clusters, right? Okay. Then apart from that, resource sharing, so it is easier with the separate namespaces within same cluster. In case of vCluster, again, it is the similar case because there it is actually able to perform the syncing with the physical servers, I mean the physical Kubernetes clusters. Okay, so it works very similar way how we have the separate physical servers. Okay, give me a second. Okay. So apart from that, the overhead efficiency. So in case of separate namespace, it's very low because we just a single cluster you managing. Okay. In case of separate clusters, it is going to be a lot increased. But when we use vCluster, it remains almost equivalent to or a bit higher side on when we have the single cluster and separate namespaces. Okay, so we'll see that how the architecture looks like to understand it even better. The architecture should be able to uh, make more clarity so far whatever we discussed. Okay, so let's talk about the vCluster architecture. So the two important aspect of coming up with this concept of vCluster and why it is important. So the two pointers that it talks about is namespace integration and isolation assurance, right? So namespace integration, when we talk about virtual clusters run inside the namespaces of another clusters. What it means that the virtual cluster or the vCluster that we create, they are actually being created on the host namespace. So suppose we got a physical machine and on that we install the Kubernetes cluster. We started the Kubernetes cluster, okay? So that becomes the host cluster, right? Under that, we create a host namespace, okay? Now within that namespace, we will have the vCluster created, right? So here, as we can see in this architecture, so we have this host cluster, the Kubernetes cluster, or you can say the physical Kubernetes cluster. On top of that, we will have the host namespace, a single namespace, right? So everything is consolidated. In case of virtual cluster, so all of those components, whatever we are going to install as a virtual cluster, they are going to be grouped together in a single namespace, single host namespace, right? So here we can see we have the host namespace, and within that we will have the the cluster vCluster installed, which will have the control plane, which we can access in this scenario. Otherwise, if we see only admins have the access to the clusters, right? But in case of vCluster, you get the access to the, I mean, the individual tenants will have access to their own namespace or their own cluster, right? With the all the admin privileges, whatever sort of uh, task that they want to perform. But yes, there are by default some restrictions created to have the right balance, because whenever we are going to work with this vCluster, we have to be able to schedule, we have to be able to create the pods, we are able to create the services, right? But what about the networking? So from networking perspective, when we see, we can see here uh, in this architecture, we got this host namespace created, we got the virtual cluster control plane, and now that is going to be able to create their own namespace. So here you can see NS1 namespace, similar to how it is created for any physical clusters, right? So we got this namespace, and within that namespace, we will have two set of properties like the high level resources and low level resources, what we call it. So on high level resources, the objects that we create, like the CRDs, custom resource definitions, right? The deployment objects, and then low level resources will be the pods under which the containers or the deployments we are doing, okay, in general with the Kubernetes. The other component is the services, which exposes those applications or deployments to the external world, right? So these are the components of the any of the Kubernetes architecture we see. So similar way for virtual cluster also, same scenario. So you can even consider this as the worker node here. So now the NS1 namespace where we have the worker node, and within that we will have the deployment objects, the high level object and the low level resources. Okay. So you can see in this scenario, we have the two namespaces with their own uh, high level resources, like in the NS1 namespace, we have deployment and CRDs. NS2, we have stateful set and the jobs that we are creating for uh, scheduling any of uh, the pods, right? So now how the networking part is taken care in this scenario. So when we talk about the networking, if we see these services and the pods, again going to use the pods and the services which is created under virtual cluster, they are going to use the same network that is created by the physical clusters. Okay, you can see this regular networking. Now under that, they are, so behind the scene, what how they are working. So we don't actually let any other objects, like you can talk about the high level resources, to be exposed to the host cluster, the host namespace, but only pods and services, which is essential for anyone to be able to utilize this. these applications or which is installed under these ports, right? So they should be able to only interact or be available for uh, us to utilize it, right? So now pod one and pod one in this scenario and the service SVC they are able to interact with the host namespace with the help of the syncer. So syncer is the another you can say the functionality of vCluster, which is really helping or doing the magic of uh, of enabling the networking for the resources that is being deployed in the virtual cluster. So what it does, it is actually copying. I mean, the syncer is actually copying the pods to the physical namespace, I mean the host namespace, okay? And then it is allowing the any sort of networking communication. So there is a continuous syncing between the pods within the virtual cluster and with the Kubernetes, the physical Kubernetes pods, right? So they are just the replica of it, you can say, and it is being synced all the time, right? With the help of syncer, and that's how the communication is being established and we are able to utilize it. So on very high level, this is the architecture of this tool. Now let's go to the next slide. Okay, so here let's see the installation and some of the commands that we want to try out to work with this tool, right? Okay, so let's move to the documentation for the setup. I have already kept it open. Let me share that. Okay. So here in this site, I mean, you can look into this documentation, this site for getting the more understanding of what is vCluster and how to utilize it better, right? So here, as part of the installation, if we see, as I'm working with a Mac system, there will be a separate set of commands for working with the other operating system, maybe Linux or maybe Windows, right? So the steps that I'm going to cover is for Mac OS. So I have already installed this software, this application for now. So the command is brew install and then loft hyphen sh tab vCluster. Okay. So the product is actually being developed by Loft, so that's why that name. Okay. Once the installation is done, we check the versioning so to ensure that the installation was complete. And then we go to the next tab for deploying any vCluster. Okay. Now let's take walk through these steps. Okay, so here if we want to create any of the vCluster first, so either we can use the vCluster command itself, or we can also use Helm or maybe the Kubernetes command after the installation. The only prerequisite request is that you should have Kubernetes already running on your system, right? So I had my Kubernetes already installed, and that's how it was able to detect. If I can take you to the other screen where, yeah, so let's see if we have the vCluster installed, right? Okay, so the vCluster is already installed here. The next command it says that if I want to create a cluster, let me just give this walkthrough with the Kubernetes command because we just want to have the right parallelism with the Kubernetes environment, right? So all of those commands works even with the Kubernetes commands, right? So here I have the kubectl create namespace vCluster my cluster, right? So that's the cluster name that I'm going to create. Maybe I can rename it to something else. So Kubernetes create namespace and let me change it to just my cluster, my vCluster. Okay, that is going to be the namespace under which I'm creating. Okay, all right. So the vCluster is created. Next is using maybe a Helm template. I don't have the Helm template installed. In that case, I have to, okay, let me go to another site maybe. Let's look into the other side. Yeah, their own official main page, right? So here they have, yeah, so this is better. I can go with this one. Okay. but still this is also looking for Helm chart. Okay. Let's see. Okay. Uh, Instead, what I can show here is like this approach. So far we have Kubernetes namespace created. Let's find out whether the namespace is there or not. Okay. So I will first try to see if I have the namespace available. I will run the command Kubernetes kubectl get namespaces, right? Okay. So I can see the namespace that we were looking for, which is my vCluster that is already being created. Okay. Now the next thing is I want to deploy something there. Okay. So let's deploy a component, be a Nginx server. So before I run that command, let's see if there is uh, anything installed already in that cluster or not. So I will run this command kubectl get pods within that cluster. So we should not be getting anything. Yeah, right. Okay. So there is nothing like anything installed, anything deployed there. So we'll now install that or deploy one component. Okay. So the command would be create deployment nginx, and we'll see if that makes takes care of it. Okay, so that says that it is already existing, which is for, okay, or maybe, yeah. So what I can do when I executed that command for deployment nginx, I can also pass on under which namespace I want to create it. So in my scenario, I have my cluster. Okay, so this is going to create the nginx deployment under my cluster. Okay, or my vCluster. Yes. Okay. So now the deployment is created under the MyV cluster. The next step is to expose it to be able to access. So before I can actually uh, expose the service, let me first see if the pod is created or not. Yeah. So here it will be get pods under my V cluster. Okay. I can see there is one pod running. I also need to expose it to the external world. So there is going to be another command to execute for, yeah, let me get that here. Okay. So my deployment was the nginx that I'm going to expose using this command kubectl expose deployment nginx and port 80 load balancer. And also I need to pass on the cluster under which I have created that, which is my v cluster. Okay. It says that already exists. Okay. I can name it something else. Or instead, because I had already executed these commands earlier, so another service already running, why not just look into that? Yeah, so let's find out if there is any service with the in Nginx. Okay, right. So this I had already executed for testing purpose. So this particular service, the Nginx is already installed in the cluster. Now let's execute, I mean, find out whether it is we are able to use it or not. So the deployment name is nginx and with having the external IP like our local host. So we'll see if I'm able to access that with the local host or not. Okay, right. So here if you see, the Nginx server is running under the virtual load balancer, I mean the virtual cluster. How do we identify that? So if I go to uh, if I just list down any of the Kubernetes objects, right? So here, as of now, I'm actually connected with the vCluster. Okay, so currently it is running there, but when I just disconnect it, the context is currently vCluster, right? So I want to now disconnect it from that context and go to the physical Kubernetes cluster, right? So if I run that, it will let me disconnect out of the virtual cluster. Let's wait for a second. Right. So now I'm not no more in the vCluster environment. So now it's not a virtual one, but I'm actually going to interact with the Kubernetes cluster itself, right? I mean the physical one. So when I run this Kubernetes get service Nginx, I should not be able to find that, right? But it is installed. So how do I get it? So let's see if I can be able to get that kubectl get services, right? So here it is not able to list down those services which are already exposed, right? So I should be probably able to get it if I use a namespace maybe. Let's see. So my B cluster, no, okay. So there is another way to get those services for outside of the main Kubernetes. Basically, let's figure out what all deployments we have in our virtual cluster. So if I go back and then get those commands, yeah. So if I see this particular command, not this, yeah, the command was vCluster, right? Hmm. Okay. Uh, let's see this other deployment that we had, which was, I guess, Nginx, right? Okay. Yeah. So here I can see that this was my earlier deployment, earlier cluster that I had created. So kubectl git pods, the big cluster, this cluster is going to show me what are the pods that we had deployed earlier. Okay, and within that, I should also be able to see the services. Let's see. All right, yeah, right. So this is what I was looking for here. So I have my service which was created and being hosted on the local host. Okay. So this is how I'm able to access those uh, those pods or the containers with the help of services for the virtual cluster. Okay, and if I want to get done with or complete the, I mean, once I'm done with my requirement, I can go ahead and then clean up those virtual clusters, okay, as I don't need anymore. So it will be more useful when we want to actually test out any of the functionalities, like with the help of a sandbox, we can just create it and then let other developers utilize it for quick testing of any features or anything, right? Okay. So we had, I guess, already disconnected, no? Right, yeah. So we already disconnected from it, and now if I want to completely delete my clusters, I can do that. So first I have to connect with the vCluster. I have to provide the cluster name as well. Let's stop it first. Yeah, okay. So the name of my cluster was this one, right? Okay, vCluster, my cluster. Okay, Why it's not able to delete? First I need to connect. Okay, we'll look into that. But yeah, overall, this is how the functionality works, and it's very advantageous in a sense. Like you can say, the use cases can be securing the multi-tenancy. Like so, if we want to have any developers, the whole control of whatever they are deploying, like even the control plane for them for any particular task, it can be given to them because now we have a separate cluster for working with any of the tenants, right? Then the cluster scaling can be performed. So if it will help in sharing or managing the resources for large scale. Okay, so we can actually share some of the resources as per the requirement, but also limit what is not required. Okay, and obviously it helps in testing the new features or the configuration without impacting the main cluster with which we are working. So, like whenever we are working with any of the Kubernetes component, we mostly see that someone, uh, I mean, having the admin privilege or in the development zone, one person working with some of the functionalities, if that is bringing down a cluster, it impacts overall the team work, right? So, it is good to have a virtual clusters to help team work in their separate environment and easily able to I mean come up with the I mean it speeds up the development process altogether if I say, right? Okay, so that is all as part of the this uh, session where we covered the virtual cluster, and I hope you you are going to test it out and figure out how that helps in your own environment, or what can be a better use case that you can think uh, of this feature. And the I can see that it's having the virtual cluster is having the open source as well as the enterprise version. But if you want to contribute to this virtual one, uh, definitely go ahead and then try it out in GitHub. Like yeah, so I think I have shared the resources. Let me see. Yeah, I've already completed the hands-on. Yeah, so these are the resources where you can find out more about the vCluster. You can also join their Slack community, right? So if I open this particular link, let's see. Yeah, so here this is their GitHub page where you can actually, if you want to, you can explore more and then even contribute to this open source project. Right? I believe they have the support for most of the clouds. Yeah. So it works with any Kubernetes cluster. So you can actually deploy the vCluster, not only the Rancher or Google Cloud, Amazon AW, EKS or Azure EKS. You can also try with the other clouds as well, right? So it is a really great tool, I would say, for working with our enhancing the Kubernetes altogether. Yeah. Yeah, so that's all as part of this session. Thank you so much.